So good evening students. So today we will solve one question where I have put one sorts where we need to find the area of a triangle when we have two squares, right? Here we have two squares. One square is this whose side is 8 and another square is this whose side is 10, right? So though it looks like a rectangle, but don't think it's an square. Okay. Now, if let's say ABCD is a square, ABCD is a square, right? Then we need to find the area of this triangle. Let's say this is a triangle which is formed. This one connecting this, and this is the third side of the triangle, right? Now, what is the area of this triangle we need to calculate. Though I have put the sorts of this particular question, I will try to explain it very clearly over here. So ABCD is one square, this is a square, first square, and this is the second square, right? So let's say this is 10 because all the sides of a square are equal. So this is 8, this is also 8, this is 8 and this is 8. So 10 minus 8, that is, let's say this is P, Q, R and C. We need to find area of triangle. Which triangle? BQD. BQD is equal to what? This we need to calculate, right? Now, for calculating the area of this triangle BQD, this is the triangle, okay? Now what we will do? Just think on this. We have two squares which are connecting with each other. One square is having a side of 8 centimeter, let's say 8 units, and another square is having a side of 10. Now we need to find what is the area of this triangle. Are you able to think of? We will use one concept. You can see this. If you just exclude the area of this triangle from the complete area of these two squares, would you be able to find it? Of course yes, because if you are deducting or subtracting this triangle BQD from the connecting area of a square 1 and 2, you will get it, right? What? If you are subtracting this from the complete area, what you need to subtract? You need to subtract three different areas. We have three different triangles. This is triangle, let's say, this is triangle first, this one, triangle QRD. This is first triangle, and triangle ABD. This is the second triangle, and triangle PBQ. This is the third triangle. If you calculate the area of this triangle, and this triangle, and subtract all these three areas from the total area of both these squares, you will get the area of this triangle BQD, right? We will find it. So let us find the complete area of the both the squares, both the adjoining squares. So complete area of both squares having side, both squares having side 8 and 10. What's that? You know that side of the square is given, then area of the square is side square. So 8 square is the area of this square ABCD, right? Now what is the area of a square PQRC? This will be coming as 10 square, right? Applying the same formula again, 10 into 10, that is side square. So we are getting 64 plus 100, that is coming as 164 square units. 164 square units is the area of the complete figure which is given, that is ABCD plus PQRC. That is ABCD plus PQRC. These both the quadrilaterals, that is both of the squares area measure 164 square units, right? Now, just to find the area of the triangle BQD, what we will do? Area of triangle, I am marking it with different color, BQD, this is equal to 164. 164, that means entire area, minus area of triangle. There are three triangles. Triangle DRQ, triangle DRQ. Again subtract area of triangle ABD, ABD, and again subtract area of triangle PBQ, area of triangle PBQ. I hope this step is very much clear to you all. Right, students? Perfectly fine. You can put up into the chat box also for any query. And we know that area of triangle DRQ, the area of any triangle is half into base into height. If the base is DR, what is the length of this DR? 8 plus 10, that is coming as 18. And what is the height of this? Since a square, this will be 90 degree, because all the sides of the square, adjacent sides of the square are at 90 degree, right? So this is 10, this is 10. So for triangle DRQ, this one, the area can be calculated as half into base into height. Base is 18 and height is 10, right? So area of DRQ is calculated over here, right? Now, area of triangle ABD, how we will calculate it? Area of triangle, you just use the same formula, that is area of a triangle is half into base into height. So what will be the base over here? 8. And what is the height? 8. Because this is 90 degree, we can say this is the height. And if you consider AB as base, then AD is the height. So half into 8 is the area of triangle ABD, this one, triangle ABD, right? Now, what is the area of triangle PBQ, the third one? That is also need to be subtracted from the complete area. So area of triangle PBQ, use the same formula, half into base into height. What is the base? Oh my God, we are not knowing the base over here. How we will find it? Just think. This is a square and QR is 10 and AD is 8. So don't you think if you extend this till this point, then you can say this will be 8, right? So this length will be coming as 10 minus 8, isn't it? 10 minus 8, that is 2, right? So we have find out the length of this value PB as 2. So if this will be the base, then half into 2 into height will be 10. This one, the side of this square PQRC, right? So half into base into height. So you can see we have calculated the area of triangle DRQ, half into 18 into 10. 18 is the base, 10 is the height. Triangle ABD area, this one, half into 8 into 8, this one, right? Now triangle PBQ, is half into 2 into 10, right? This one, PBQ is this triangle, right? This one, this is PBQ, and this is the second triangle which we have taken, whose area need to be subtracted from the complete area. So we just come up with the figures which need to be find out. So 164 will be same. Just take 1 by 2 common from all these three. So in the bracket we are left with 18 into 10, which is 180. Now 8 into 8. What's that? Oh, let me squeeze it little. Just a second. Yeah, I think it's visible now. Yeah. So 18 into 10 is 180 and 8 64. So it will be coming as 64. We have taken minus as common. So 8 64 and 10 to 20. So it will be coming as 164 minus half into 180 plus 60, 240 plus 20, 260, 180, yes, 180 plus 64 plus 20, just add it. 180 plus 20, 200, 264. So this will be coming as 264. Now deduct from this 2, just cancel out. 2 1 2 2 3 2 2. So it will be coming as 164 minus 132. So 164 minus 132 is the area of what? Is the area of this pink triangle, triangle BQD, which we need to calculate. So what will be that? What will be that? 164 minus 132 will be coming as 32. So 32 square units is the area of triangle BQD. So this will be coming as 32. 32. Right? I hope you understand how we have solved this question. Right? So here we have two squares which was given into the question. The two squares which are placed adjacent to each other, right? Where we have 8, one square is having the side of 8, another square is having the side of 10. Now this is the triangle, just this diagonal is connected, diagonal of the first square BD, and from B to Q and then D to Q. So we need to find the area of triangle BQD. We are not able to find out direct formula for this. So what we did, we just simply taken the complete area of both the figure, that is both the squares, that is side square, that is 864 plus 100. So 164 square units is the area of the complete figure, right? So from this complete area, we need to deduct the area of triangle DRQ, this one, right? And again from the same area, deduct area of triangle ABD, which I have shaded it over here, right? And also deduct the area of triangle PBQ, this one, right? We find out the area of DRQ as half into base into height. The base will be 8 plus 10, 18. And you know that sides of the adjacent sides of the square are at 90 degrees. So we can say this is the perpendicular one. And QR, you know the length of QR is 10. So half into base into height, simply apply it and you are getting the area of triangle DRQ, right? Similarly, if you are calculating the area of ABD, that will be coming as half into base into height. What is the base? Base will be 8. Again adjacent side, it will be at 90 degree, right? So height will be AB, that is 8. So half into 8 into 8. This is coming as the area of the second triangle. Similarly, the area of third triangle PBQ is calculated as half into base into height, right? So we have find out the total area of these three triangles, right? So deduct all these three areas from the total area of 164 to get the area of this pink triangle BQD, right? This one, triangle BQD. So how we have shown the steps how we have calculated it. So 164 minus half into 18 into 10, this is coming at, taking 1 by 2 as common, in the bracket we are left with 180 plus 64 plus 20. So when we are subtracting 164 from 132, we are getting 32. So 32 is our answer, and this is the area of this pink triangle, right? Now let's have some queries. Pranav Kumar, next. I was not there. Give me 30 seconds time, please. Yeah, Pranav, please. So you want me to explain this question again? Yes, Pranav? Yeah, you can be here. I will explain it again. Okay. So I'm explaining it, right? Okay. Here we are given two squares. One square with side 8 and another square with side 10. Don't see it's looking like a rectangle, but the construction is not proper as per measure. Just consider this as a square, right? So two adjacent squares are there. One is having a side of 8 and one another is having a side of 10, right? We know that all the sides of a square are equal. So we have considered this 8, 8, 8 and similarly 10, 10, 10 and PC is also 10, right? We need to calculate the area of this pink triangle, that is triangle BQD. We need to find out this triangle area. So how we find it? Okay, Pranav, I need not to explain. That's fine. I hope you understand it perfectly fine. So coming on to the next, okay. So coming on to the next question. Actually, I have just put up the published the sorts of this question, so I explained it. Now I will take another question of a square in the class today. Okay, so it's let me consider here. Okay, here also we have two squares, right? We have two squares, and the diagonal of it's given that the diagonal of one square, let's say ABCD is one of the square and PQRS is another square, right? Now we need to find that what is the ratio of the area of these two squares if the diagonal of first square is twice the diagonal of the second. So let's say if SQ is this PQRS is having a diagonal of D length and ABCD, then ABCD is having a diagonal of 2D, double that of the first, right? It's given. This is given criteria of the question. I have also published the sorts for this question, but I need to explain it over here so that any queries which are coming to me, I will be explaining it, right? So this is a criteria given that the diagonal of this bigger square is twice that of the diagonal of the smaller square. Now, what we need to find? We need to find the ratio of the area of both squares, right? That is ABCD and PQRS, right? So let us assume that the side of the square ABCD, let side of a square ABCD equal to x. Let us assume it x, x, x and x because it's a square, so all the four sides are equal, right? Now for the second one, let us assume similarly, let us assume the side of a square PQRS as y, right? So this will be y, 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 y and y. We know that the adjacent sides of a square are at 90 degree, right? So this will be 90 degree. Similarly, in this square PQRS, this will be 90 degree. So why I am just highlighting it over here? Because we will be able to apply Pythagoras over here in these two triangles, okay, which is captured by two sides of the square and the diagonal of that square, right? Now area of triangle, not don't say area, just apply Pythagoras over here. It will just resolve our issue, okay? It will resolve our question. What we need to calculate the ratio of the area of the two squares. So for this apply Pythagoras. So just mentioning over here by Pythagoras theorem. What is Pythagoras theorem? You know that p square plus b square equal to h square, where p is the perpendicular, b is the base, and h is the hypotenuse, right? So in triangle BCD, we can say that x square plus x square equal to 2d whole square. We can say that x square plus x square equal to 2d whole square, isn't it? It's simple Pythagoras, right? Okay. Now, similarly, in triangle, take the triangle of the smaller square. In triangle, what? QRS. In triangle QRS. In triangle QRS, what we will see? Again, apply the Pythagoras, we get y square plus y square equal to d square, right? Y square plus y square equal to d square. Fine. So from here, what you are getting? You are getting 2x square equal to 4d square, right? 4d square. And from here, from the Pythagoras on triangle QRS, we get 2 times y square equal to d square. Is it clear to you? Is it clear to you? Perfectly fine. So here you can just see in this equation, and in this equation for the another square, you can see d square is an element, which is just common in both the equations. You can see, observe it, right? Your observation just matters a lot. Yeah, this is the d which is common in both. Now what we will do, we will just put up the value of this d square over here from equation number 2 to equation number 1. If this is equation number 2 and this is equation number 1, then what we will get? Just simply put up the value. Now from this one, from triangle BCD Pythagoras, we are getting 2x square equal to 4d square. 4 times d square. So in place of d square, what we will do? We will just substitute the value of d square from equation number 2 to equation number 1. So this is 2y square. So just simply put up the value of 2y square over here, right? I just replace the value of d square as 2y square by using equation number 2, right? Now what we will do, you can see 2 2 cancelled out, 4 will be cancelled out with 2. So x square is equal to 4 times y square, or we can say that x square by y square is equal to 4 by 1. But what is x square? You know that. Yes, x square is the area of the bigger square and y square is the area of the smaller square. And what we need to find out? This is the exact thing which we are searching for. This need to be calculated. So we have ultimately find it out. We find it out that the ratio of area of both the squares. What's that? This is coming as 4 is to 1, right? So we can say that area of both the squares are is equal to is 4 is to 1, right? So this is our answer. So 4 is to 1 is the ratio of the area of a square. Which one? ABCD, and area of a square PQRS. PQRS. So our answer is 4 is to 1. So this is our answer, right? So we have shown this question. I have already put a source of this question few time back, and now I have tried to explain it very clearly. Any query, let me understand. I'm just checking the chat window. Yes, yes, students. I think it's visible to you clearly. So we have taken two separate questions over here in this class. Okay. This was the question. I am just quickly giving a recap of this. Two squares are given to us. One is having a diagonal double that of another square. So this is the only relation given, 2D and D, right? Diagonal of a square one is double that of diagonal of another square. Now we need to find the ratio of the area of both these squares. So what we did, we have just assumed the side of this square as x and side of another square as y. Now by Pythagoras theorem, we know that x square plus x square equal to 2d whole square. What is that? That is base square or plus perpendicular square is equal to diagonal square, right? Now we can apply Pythagoras over here because we know that adjacent sides of a square is at 90 degree, right? So applying the Pythagoras, we get x square plus x square equal to 2d whole square, which is coming as 2 times x square equal to 4 times d square. Similarly, applying Pythagoras on the another square, that is a smaller square, we are having the relation y square plus y square equal to d square, coming as just resolving as a 2y square equal to d square. So just substitute the value of d square from here, from equation number 2 to equation number 1. So we get 2x square equal to 4 times 2y square, right? So we get the ratio of x square by y square as 4 is to 1. So 4 is to 1 is our answer. That is the, because x square is the area of a square, the bigger square ABCD, and y square is the area of a square PQRS. So ratio of these both the areas is coming as 4 is to 1. So 4 is to 1 is our answer, right? 4 is to 1 is our answer, right? So students, I hope you liked the videos and live session. We have explained the questions of squares over here, and I will like to just become online and live next in another session, right, with some different topic. So keep on learning and happy learning. Bye bye. I am closing the session now. Like and subscribe. Bye.